Good morning. So let us continue with the further topics on rational numbers. So today we will be talking about the division of rational numbers. As we all know that division means repetitive subtraction. When we have studied the multiplication, we have talked about the repetitive addition. So when we talk of the division of any numbers, we are talking of the repetitive subtraction of those numbers. So let us come to the topic division of rational numbers. Now when we talk of division of rational numbers, we say that whenever any two rational numbers are divided with each other, then there is one condition which needs to be followed. I will let you know that what is that condition, and the division usually takes place in two steps. Let's understand what are the two steps. Suppose I have a rational number a upon b which has to be divided by the other rational number c upon d. So what condition is applied over here is that this c upon d should not, or it should not be equal to 0. What is the condition here? This c upon d, the other rational number which is dividing a upon b, should not be equal to 0. So this is the condition which exists or prevails, or which is of keen importance when we are doing any division of rational numbers. So let's see. Now if a upon b is the first rational number, the next step is that I will be writing the multiplicative inverse of c upon d. So what is the multiplicative inverse? That is d upon c. Clear? Now this is the multiplicative inverse. Then once we reach to the second step of division on rational numbers, then we are supposed to do the usual multiplication of rational numbers. Then after writing the first step of division, we shift or we move further to the next step of division. At this time, we are going to convert the second rational number to its multiplicative inverse, and after converting it into multiplicative inverse, this division sign will get changed to multiplication sign. And after this step, we are going to multiply the two rational numbers as we have done earlier. Similarly, we are going to multiply them. A multiplied by D and B multiplied by C will give you E upon F, that is your result of the division of the two numbers. Now here, the first number is known as dividend. The next number is known as divisor, and the result which you get is known as quotient. Clear? Now see, this is dividend, this is divisor, and that is quotient. So this is how the division of rational number takes place. Now this was the symbolic representation of division of rational numbers. Let's take one example and understand. So the example is 1 upon 2 divided by 4 upon 8. Okay, so these are the two rational numbers in which the division has to be done. So the next step is, first of all we will check that the second rational number does not equal to 0. So it is not, it is 4 upon 8. So 1 upon 2 division sign gets changed to multiplication sign. Then we will write the multiplicative inverse of 4 upon 8. That gives us 8 upon 4. Clear? Now 1 upon 2 multiplied by 8 upon 4, we are going to do the usual multiplication, which is 1 multiplied by 8 upon 2 multiplied by 4. that is 8 upon 8, which gives you 1. 8 got cancelled by 8 and the result is 1. So what is the quotient of the division of these two rational numbers is 1. As I have explained that the first number is known as the dividend. The second one, which is dividing the first rational number, is known as the divisor, and the result which we get here is known as the quotient. Now let's take some more examples to understand the same. So I have minus 6 upon 25, okay, by 3 upon 5. Clear? So what I have to do? I have to divide minus 6 upon 25 by 3 upon 5. So this by will change to division sign, and it means that minus 625 has to be divided by 3 upon 5. So how do we write it? Minus 6 upon 25 divided sign instead of by 3 upon 5. Clear? Now let's move this side. Minus 6 upon 25, division sign changes to multiply sign, then multiplicative inverse of 3 upon 5, which is 5 upon 3. So this is how the given question comes to the solving stage. What is this stage known as? This is known as the solving or calculation stage, where finally you can solve the given question of division. Clear? Now minus 6 upon 25 multiplied by 5 upon 3. Now here when we talk of the division, there is the direct cancellation of the numbers which can be done. What do you mean by direct cancellation? You have to see whether any of the numerator or denominator which is there in the two rational numbers are multiples of each other or not. So let's see. Here 3 and 6 are multiple of each other. That means 6 is multiple of 3. And secondly, 25 is multiple of 5. So they can be cancelled directly or they can be divided directly, instead of the fact that we multiply the numerator with the numerator and denominator with the denominator. Let's see. 5 cancels 25 5 times, right? What I did? 5 ones are 5, 5 fives are 25. So instead of 25, what I have done? I have written here 5. So that is the direct cancellation, or you can say the direct division. Here 3 cancels minus 6 to minus 2. So what is left? Here in the numerator you are left with minus 2, and here in the denominator you are left with 5. So the quotient of the given question of division is minus 2 upon 5. Now if suppose I do not want to opt this method, what am I supposed to do? I will be following the regular method of multiplication of rational numbers. So what I have to do? Minus 6 multiplied by 5 upon 25 multiplied by 3. That means I have multiplied the numerator with the numerator and the denominator with the denominator. Then minus 6 into 5 gives you minus 30, and 25 into 3 gives you 75. Now this is not the simplest form of the given rational number. Now you need to change it. So if I have to find out the HCF of these two numbers, what is it? It is 15. So when I divide 30 by 15 and 75 by 15, what do I get? Minus 2 upon 5. So which is same as in this case. Now what is the benefit in following the first method? The benefit in following the first method is that you do not have to find the HCF of big numbers to reduce the given rational number to its simplest form. So see, the entire calculation has been done here itself, and you get the simplest form of the rational number. That means the quotient which you get is already in the simplest form. You do not have the need to convert it into the standard form or simplest form of the given rational number. You directly reach to a quotient which is already in the reduced form. But in the next case, what is happening? First you are multiplying, you are doing double labor. First you are multiplying, then you are dividing, then you are reaching to the final product, final quotient or final result, which says that minus 2 upon 5, minus 2 upon 5. The quotient is same in both the cases, but first one was easy, you did everything directly, and in the second case, first multiplication, then division, which is also a time taking process, and it consumes lot of time when you are attempting such questions in your exams. Now let us take few more examples of the same. Now the next example is 90 upon 160 by 3 upon 5. Clear? Now again we are going to follow the same method. 90 upon 160 divided by 3 upon 5. What is the next step? We will change division sign into multiplication sign, and 3 upon 5 will be changed to its multiplicative inverse. 90 upon 160 multiplied by 5 upon 3. Now again you have to observe whether the two rational number comprises of numerator and denominator with their multiples or not. So yes, 90 and 3 are multiples of each other. That means 90 is multiple of 3, 160 is multiple of 5. Or there could be another method which could be done. Now look at 90 upon 160. It seems to be very difficult to solve this because sometimes we get puzzled with the tables and we do not understand what to do. So to avoid that situation, what we can do, whenever you find a 0 in the numerator of any of the two rational numbers or a 0 in any of the two denominators, the 0 gets cancelled with 0 easily. Okay, so this 0 gets cancelled with 0. So 0 got cancelled with 0. Let's write it again. 9 upon 16 multiplied by 3 upon 5. We are supposed to write the multiplicative inverse, that is 5 upon 3. Clear? Now 3 cancels 9 3 times. Clear? 16 and 5 and 3 and 16 do not have anything in common. That means they are not the factors of each other and also they are not the multiples of each other. So we cannot solve them. So what are we going to do? We will be multiplying rest of the left numbers. So in the numerator we are left with 3 multiplied by 5, and in the denominator we are left with 16 into 1. So 3 5s are 15 and 16 1s are 16 is 15 upon 16 is the final quotient of the given division sum. Let us take one more example to be more clear about the concept of division of rational numbers. So my next question is 11 upon 24 by minus 5 upon 8. Clear? Again we will come to the same stage. 11 upon 24 divided by minus 5 upon 8. This will give you 11 upon 24 multiplied by 8 upon minus 5. So in this case, see, a negative sign has come in the denominator. So you do not have to worry right now about this negative sign. You solve the question and then this negative sign could be shifted to the numerator later on once you get your quotient. Okay, so let this negative sign remain as it is in the denominator. Now, do we have any common thing which could be cancelled? Certainly we have. 8 cancels 24 3 times. Is it clear? Now what am I left with in the numerator? 11 multiplied by 1. In the denominator, 3 multiplied by minus 5. So my quotient comes to be 3 multiplied by minus 5, that is minus 15. Final quotient is 11 upon minus 15. Now this is not the standard form. To make it a standard form, we have to multiply the numerator and the denominator by minus 1, which gives a final quotient minus 11 upon 15. So what is the final quotient of the given multiplication is 11 upon 24 when divided by minus 5 upon 8 gives you minus 11 upon 15. So certainly we have multiplied 11 upon 24 with the multiplicative inverse of minus 5 upon 8 and we have got the quotient minus 11 upon 15, which is the standard form, reduced form of the given rational numbers. Clear? Now let's come to the properties of division of rational numbers. So as we have studied many properties in the addition of rational numbers and multiplication of rational numbers, we have very few properties when we talk of the division of rational numbers. Now let us take one more example on division of rational numbers. If suppose the product of two numbers is, this is a kind of problem sum, is minus 28 upon 27. Okay. Now, if one of the number which is given to you is minus 4 upon 9, then you have to find out the other number. Then find the other rational numbers or rational number. Now see, the product of two rational numbers. Clear? The product of two rational numbers is minus 28 upon 27, and if one of the rational number is minus 4 upon 9, you are supposed to find out the other rational number. So let the missing rational number. Okay, so now x is the missing number which is we need to find out in the given question. So according to the question, x is the missing number and the number which is given to you is minus 4 upon 9. Okay, now x is the missing rational number and the rational number which is given to you is minus 4 upon 9. When these two are multiplied, their product comes to be minus 28 upon 27. Okay, so this is the product which you get. Now, how are you going to solve this question? See, here x and minus 4 upon 9 are multiplying each other. If I transpose this minus 4 upon 9 towards right hand side, its sign will get changed to division. What will happen? Its sign will get changed to division. Now, what will I get as my question now? x is equal to minus 28 by 27 divided by minus 4 upon 9. So this will be the question equation which I will get, or this is the question which I am getting. Right? Now we will follow the same steps. Minus 28 upon 27 multiplied by reverse of the given rational number, or you can say multiplicative inverse of the given rational number, that is 9 upon minus 4. Now you don't have to make any change to the negative sign, as I have explained earlier also. Now we will be cancelling them. 4 cancels 28 7 times. 9 cancels 27 3 times. The result which I get after the cancellation of these numbers is here minus 7 upon minus 3. How? Because here the 4 had minus sign, so 3 also has got the minus sign, and here minus was present with 28. So 7 also got the minus sign. Now these two negative signs will be cancelled, and the quotient which I will get is 7 upon 3. Clear? Now the value of x comes to be 7 upon 3. Now let's substitute the value of x here and verify whether we are getting the same product or not. So 7 upon 3 instead of x multiplied by minus 4 upon 9. So 7 multiplied by minus 4 is minus 28, and 3 multiplied by 9 is 27. So that means that the missing number is certainly 7 upon 3, because here also I have got the product of the given two rational numbers which was mentioned in the question is minus 28 upon 27, and here also I have got the same product when I have found the value of x as 7 upon 3. Now let us talk about the properties of division of rational numbers. So as we have already discussed that when we talk of the properties of rational numbers related to addition and multiplication, we have many properties. But when we talk of division of rational numbers, we do not have that number of properties. The first property that we talk of in division of rational numbers or we can say the properties of division of rational numbers. Here, the first one is the closure property. Clear? The closure property says that whenever two rational numbers are divided with each other, the quotient is always a rational number. That we have already seen in the many examples that we have done. Okay? So, the closure property says that if suppose A upon B is divided by C upon D, whatever you get as E upon F is also a rational number. It is also a rational number. Clear? Now, let us take one example quickly to understand that. If suppose 6 upon 8 is divided by 2 upon 3, clear? What are you going to get? 6 upon 8 multiplied by 3 upon 2, because we are supposed to write the multiplicative inverse. So, 2 cancels 6 3 times, right? Then 3 3s are 9, and upon 8 is the quotient which I will get. So certainly 9 upon 8 is also a rational number. Now the next property talks about or the next property of division says that division is not commutative. Okay, division of rational numbers is not commutative. Clear? It is not commutative. That means what? If suppose you write P upon Q divided by R upon S, okay, it will never be equal to R upon S divided by P upon Q. That means if you have changed the order in division of rational numbers, then certainly the product will not remain the same. That means the result will not remain the same. The quotient of the two rational numbers will not remain the same. Clear? So this is the commutative law, which says that whenever two rational numbers are divided and if their order is changed, their quotient or the result which you will get in both the conditions will not be same. Okay, now there are some important points related to the division of rational numbers which you have to keep in mind. The first point is, if P upon Q is divided by R upon S, it can be represented as P upon Q upon R upon S. You can solve it like this also. Okay. Now see, P upon Q upon R upon S is what? That instead of writing the multiplicative inverse, if you write it in this form, you will result in what? P upon Q, that is P upon Q, okay, multiplied by S upon R. That means this S will go up and the R will come into the denominator. So certainly you will reach to the multiplicative inverse form, that is the second step of the division. Okay. The next point that you have to keep in mind, which is very important, related to the division is if in any rational number the numerator is 0, okay, maybe in denominator you have any of the positive or the negative integer, it does not make any difference. The result in these three cases will always be 0. The result in these three cases will always be 0, because whenever you divide any number by 0, your quotient remains 0. Now the third and last important point related to division of rational numbers is, if suppose any rational number, that is A, is divided by 0 or any other rational number B divided by 0 is not defined, what is not defined in terms of rational numbers also. That means it does not exist. We will not come to any concluding result in such case. Okay, so what all we have discussed today? We have discussed about the division of rational numbers and we have discussed about the properties of division on rational numbers. Now let us come to the next topic.